Okay, need the height and the weight in the Excel sheet, copied and pasted that into SPSS. So I'd go and make sure you copy the height, which the first person was 72 inches tall, the last person was 68 inches tall, and the weight, 167 pounds for the first person, 125 pounds for the first person. Okay, first let's go to variable view and label our columns height and weight. So the first column is height. I'm going to call it just that. Second column is weight. We've only measured in whole decimal places. So I'm going to delete the decimals. And then for measure, these are both scale variables, meaning interval or ratio. And height and weight are both ratio scale. Okay, so we go back to data view, and now we see, okay, height, we have our 10, weight, we have our 10. So we want to find ours, is height and weight correlated? Meaning, are taller, do taller people weigh more, or less? Likewise, do heavier people, are they taller, or shorter? Or are the two variables completely independent of each other? Likely, as you get taller, you weigh more, or maybe as you weigh more, you end up being taller. Again, this is correlation, not causation. So we just go to analyze, scroll down to correlate, and then bivariate. And we see both height and weight as scale variables. I held down the shift key, highlighted both of them. Just bring both variables over into the variables column. I moved it from left to right. Make sure Pearson is checked because that's Pearson's correlation coefficient, or R. We want two-tailed, and then you can leave this checked for flag significant correlations. That means in the output window, the computer will tell you, which ones are significantly correlated and which ones are not. Then all you have to do is hit OK, and the output window appears, and we get this correlation matrix. So let's start with this first box right here. This is comparing height to height, which is a correlation coefficient of 1, which is to be expected, because any variable correlated to itself would have a perfect positive correlation. Likewise, weight to weight has a correlation coefficient of 1. Both of these have an n of 10, meaning there was data points. There was 10 individuals who we used their height and weight to see if they were correlated. What we really want are these two, which are the same. This is correlating height to weight. This is correlating weight to height. Again, which one's x and which one's y, doesn't matter for correlation. So we see the 0.891. That's our correlation coefficient. It has 2 stars next to it. We go down here and it says 2 stars. The correlation is significant at the alpha of 0.01 level. P-value is less than 0.01, and actually the p-value is given on this sig two-tailed row, which is 0.001. So the p-value is 0.001, which is less than 0.05, so it's significant at the alpha 0.05 level. Likewise, as I said here, it's significant at the alpha of 0.01 level because the p-value is less than 0.01. The n of 10 just reminds us again there was 10 people used in this correlation. The same information is presented down here. If you had more than just 2 variables, your correlation matrix would just get wider and longer. If you had 3 variables, you could look at each 2 at a time, and the first row would compare all variables to the first variable. In this case is height. Second column would be all variables correlated to weight. All right, that's correlations in SPSS.